Here we are going to discuss some beautiful problems of optimization. Suppose we have two cities and we have to, or I can say two centers. If I have to find a way such that I join them with the least amount of concrete used, that I have to make a road joining this city or center to this one, using the least concrete, how will I make this road is this straight line, and it will be the least than any other one. But now the question comes to that if I have three such centers, how do I join them to get again the least concrete used? So suppose if I have this as one center and another center, and I have suppose one more. These are my three centers. Now the thing is, how do I join them such that they uses the least concrete? So maybe I can just join these them by triangle, or maybe I have to find a way. Say let's call them A, B, C, and I call this as midpoint the F, and then I join them like this, having a city center from these all centers, such that what I want is now AF plus BF plus CF, this thing to be minimized. So what will be this F point? So for this, actually this point which will be the minimum one is known as Fermat's point. And what will be this point for any triangle? We can find out that it holds a property. And what is this property? Let's talk about that. So for the property would be that all these angles are going to be 120 degree. No matter how, if this is like a this type of triangle, no matter where I put ABC, this point will always be such that this makes 120 degree each from this vertices and point. So we can think of the proof as, let me remove these, and we go a little bit towards maths form of it. So maybe I can get this thing closer also to make it more clear. So I have a triangle, say A, B, and any point C I chose, and then I have to find a point F such that all my these lines AF plus BF plus CF is minimum. So what I do is I just trying to join this triangle, just doing a little bit construction to understand what will be the property, how to find F. And now what I'm going to do is take this AFB and rotate it by 60 degree. So suppose now there is the some point F which holds this property at which this is minimum, and what I do is I take this and rotate this triangle ABF by 60 degree having hinge at B. So what I get is this new triangle which looks like this and this. So this is correspond to this, which is F dash, this is A dash, and this angle is 60 degree. And now of course I just rotated this triangle by 60 degree over here. And I know this doesn't look like straight line, so let me make it more straight. I'm very bad at making straight lines. Okay, so now because I rotated the same triangle, so I can say that BF dash will be equal to BF, because this have been just shifted like this. So BF dash is equal to BF. And now suppose if I join this, what I can say that in this triangle F dash B, this and this are equal, and this is 60 degree. Now because these two are equal, so this angle should be equal to this angle, and this is 60 degree, so these both should be 60 degree each, right? And if all of them are 60 degree, what I can say is this is an equilateral triangle. BF dash is equals to BF is equals to F dash F. So all these lines are equal. Let me now erase these chaos and just say that okay, now I know that these lines are equal. And now what I know is that my BF is now equal to F dash F. What I know is actually BF is equal to BF dash and is equal to F dash F. Now when I have to say what I wanted to minimize is AF plus BF plus CF. Now this AF is equal to A dash F, right? So in my this term, I wanted to minimize this, and what I can see is AF is actually equal to A dash F dash, because I just rotated this. BF is equal to F dash F, and let CF be CF. So now if you see what it is, let's read backwards. CF plus F dash F plus AF. I want this to be minimum. This to be minimum. And when will this be minimum? This line, when these all are in a line. If they are all in a line, then this sum is going to be minimum. And as if they are in a line and this is 60 degree, then this angle automatically comes to be 120 degree, because this has to be in a line. This has to be in a line, then this angle comes to be 120 degree as this is 60 degree. And so I found out like for BFC that this is 120 degree. Similarly, we can prove AFC and AFB all will be 120 degree each. So this is how we can find out this F will be this point from where if I join all the vertices gets the minimum distance is the point where all angles come equally to be 120 degree, and this point is also known as Fermat's point. So now there is another thing that suppose rather than 3 points, you have 4 points, and you have to find how do I join. Okay, so let's just start. Now there is another problem, which is this, that if I have 4 points, let's say they are the vertices of a square, and how do I join them such that they have this minimum distance, and so we have to lay down the road such that least concrete is used, but from any of the point I can for surely go to any other point. So maybe one thought could come is just join by these diagonals, but actually there is a better way, and maybe you can try that out. And so we actually will see somehow that how it's something related to the last proof we did, which was this 120 degree. So maybe I'm just coming directly to the solution of it, that how would it look like will be this. This will look, actually the minimum path will look like this. All these are straight lines, please let it think that they are straight lines. So bad. And again, all these angles will be 120 degree. So this is how the minimum concrete will be used, or the least distance thing for these 4 points. And no matter where these 4 points are, I just took them for the square. Even if you change it to anything else, suppose here you take the C now, again it will modify itself into a way that these intersecting points will be at this 120 degree. So this thing will be followed always, this 120 degree pattern for these 3 vertices thing. So we can look actually further on how we can see from nature these optimization way. Nature, like we did all these calculations, and like for this even a further more complicated I would say calculation, but nature within few seconds can tell us with using soap films and many other, which we might discuss, let's see in some other videos. Thank you.